This video is a tutorial of how to display time series data and alerts on Grafana. For this tutorial, we'll be working with GPS height data from TZVOLCANO. This data measures the height of a GPS station in Tanzania. To start displaying this data, we need to create a new dashboard. To create a new dashboard, click on the dashboard drop-down arrow in the upper left-hand corner and you'll find a Create New button. This button creates a new empty dashboard. To title the dashboard, click on the Settings option in the upper left-hand corner. Under the General tab, we can change the title to an appropriate name. Since the data we'll be using is at the station titled OLO3, let's call this dashboard OLO3 Height. Now, we can create a panel to display the time series data. Right now, the dashboard has empty panels. On the left side of the panel, there's an option to create a new panel. We can create different displays depending on the data that we're displaying. For this data, we'd want to create a graph. Since we haven't linked any data onto the graph, the panel displays an empty plot. To edit the panel, click on the panel title and then click on the Edit button. Let's start with the general options of the panel. For the title of the panel, let's name it OLO3 Height because we're displaying the height data from the OLO3 station. We can add a brief description of the panel to explain the background to the public. This GPS station is the site on the Natron Fault adjacent to the volcano. Regarding the dimensions and templating of the panel, we can leave these as default. These options depend on visual preference of the panel size. The Metrics tab contains the data import options, so some basic syntax of Grafana is implemented here. The from keyword is used to define where the data is coming from. For this dataset, we pull data from the TSData dataset. This will graph all of the datasets in this data stream. However, we denoted that the specific var value of OLO3's height data is 6 in the data stream. We want to select the means of the field values and group them by time. The fill function fills all missing data points with the desired value. Here, we want to fill the empty data points with null to show that there is a break in the data being streamed. Since this data is the OLO3 height data, we can name the data OLO3 height in the alias by section. And the graph is automatically set to being formatted as a time series. The group by time interval depends on how often your metrics are being written into InfluxDB. For TZVOLCANO, we write our metrics every 10 seconds. Since this is a lower limit, we enter greater than 10 seconds. The next tab to complete is the Axes tab. We want to show the left y-axis as a short number. The scale of the y-axis is linear. If you're graphing an exponential dataset, one of the logarithmic options would best fit the dataset display. The dataset we're using is in meters, so we can label the y-axis meters. We don't need to display the scale on the right y-axis. For the x-axis, we want to show the time that the data has been taken. For the legend, we want to show it on the graph. The default setting is on the lower left-hand corner of the panel. You can move the legend to the right and show it as a table. Another option is to display specific values. You can display the minimum, maximum, average, current value, and total values on the bottom of the display. These values would be from the data on the panel's current display. Since our graph only has one dataset, we don't need to worry about hiding different series. In the Display tab, there are various options depending on what needs to be emphasized in the data. You can choose to have any combination of bars, lines, and points. For the GPS data, it is not technically a line graph because we don't want to assume that the distance covered in between the data points is linear. So we're going to choose the bars and points options. The points will show a more accurate representation of our data because it is not a continuous data flow. And we're choosing the bars option because it better shows an absence of data than just singular points. We can choose the size of the points and lines if we'd like. For the hover tooltip, when you make multiple displays, you can have your mouse hover over one graph and have that same point show for each graph on the dashboard. Grafana allows for the creation of alerts and thresholds for datasets. Once the evaluated data exceeds a condition set by the administrator, the Grafana site will alert someone. From here, you can choose to create a threshold or an alert. A threshold will accomplish the same thing as an alert, but it only evaluates a single value and does not notify a specific email. For example, if I wanted to set a display threshold of 1,482 meters so that values that are below that point are critical, I would choose the GT option with the critical option. The other options are similar to the simple display options. Alerts are far more flexible than thresholds. They can evaluate averages, minimums, maximums, or other values set over a span of time. Once a limit is exceeded, Grafana will email or send a notification to whichever notification you'd prefer. Start by creating an alert and naming it. This is the name that will show in the alert to the notification channel. As an overview of the alert, we'd like to create an alert that evaluates the averages of 3-hour time periods every 1 hour. So we're going to evaluate this alert every 1 hour when the average of the query, letter A, because that's what we defined it as in the metrics tab, from 4 hours ago to now. Now say we want to bound our expected values between 1,482 and 1,483.5 meters. Then we change this option to is outside range, and we'd insert our condition values here. Regarding null values, we're just going to leave the alert on no data because no data doesn't have much significance. If there is an execution error, then something has occurred with the alert, so we'll set this to alerting. To check the alert, the test rule allows you to run the alert with the current data. At this point, we have our alert set, but it's not alerting anywhere. In order to set up a notification channel, go to the Grafana logo in the upper left and click on the alerting dropdown. Then, go to the notification channels tab. We're going to add a new channel and add the information. So, let's alert John Doe through email john.doe@email.com for all alerts on this Grafana site. We'd like to include an image of the data on the alert in the email. If you'd like, you can send a test to the email to make sure it properly works. Now, since we chose to alert John Doe on every alert, he is automatically added to the notification channel on the OLO3 height alert. You can check by going back into edit mode and finding the notifications under the alert tab of the panel. You can also add a message that is additional to the image and title of the alert. To create a message, go to the alert tab and then to the notifications tab on the left of the panel. You can see that John Doe was automatically added to the alerts list. For the message, let's say that the OLO3 height data is out of range. For the last tab, time range, this allows for the graph to always display a certain time set of data. For example, if I'd like to display the previous 2 hours of data from the current time, I would enter 2 hours. If I'd like to see 2 hours of data from 3 hours ago, I'd enter 3 hours here. You can either choose to hide the time override or not. For our purposes, we'd like the user to be able to change the time set, so we're not going to explicitly set a time range. So now, we've finished creating a dashboard, panel, and an alert on Grafana and are ready to start analyzing data.